Here we are. Okay, we're live. We just said a prayer. We have Jeff, Jesse, Ruth, and Jamie in attendance. So here we go. All right. So was there any questions on part one?
Not me.
I don't think so.
Okay. And then if we just work through part two, so I'll read question 7, confidence interval. In an October 2008 poll, 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. So A, find the proportion of those surveyed who have been in an automobile accident in the last 5 years.
So at 68%, 0.68.
So that's just dividing 684 by 1,006. And I'm assuming, like on a quiz, we would just put 0.68 representing 68%. Okay. Someone want to read B?
I'll
I get it.
Oh,
Go ahead. Go ahead.
Check requirements in constructing a confidence interval for this data. So then we did that formula for the N times P hat, and I got 684, that one, and the other number 322.
This one I was confused on.
Did you use the formulas, the two formulas?
I don't know which formulas to use.
Okay. So it would be the one where it says the requirements. You need to use N times P greater or equal to 10. And N times 1 minus P is greater or equal to 10. Do you remember that formula?
Okay, yeah, I found it.
Okay.
So I just used that to find the answer.
Yeah.
Okay.
Someone wants to take C? Or
To determine the margin of error for 95% confidence interval based on these data. This is the one I struggle with trying to do it by hand. I finally just pulled up the program, and so it's 0.65 and 0.71 or 709.
So the margin of error, especially like on the last unit too, that was what I had the biggest struggle with, was the margin of, determining the margin of error.
In the book, let's see. Let's go back to the book.
Oh, sorry, I gave you my response to D.
Yeah, that's not what I got, Jeff.
Yeah, well, you probably got what I got, and I was frustrated with this part of the assignment because I couldn't get what he was doing in the video. I couldn't get the same number he did. So, and it was frustrating because they have nothing to show you. They just tell you what it's supposed to be. So if you can help me out here, I would be totally happy.
Okay.
Wasn't this one like the z with the star and then the square root of p hat times
Yes.
1 minus p hat divided by n, and that's all square rooted?
Mm-hmm.
Yes, that's the margin of error
Okay.
formula.
So
Yeah, it was the p hat plus or minus z, right?
yeah, no.
No. It's just the second part of that formula.
It's
Just
the
the
p
z.
hat times 1 minus p hat divided by n, and that's all square rooted.
Yes. The z, the critical value z
Mm-hmm.
Is the 1.96.
is the
Right.
1.96 times the square root of the
0.
p hat and so forth. That whole thing is, when you calculate it, that's going to be your margin of error for the proportion. Okay. For this unit. I don't know how to say it.
No, you're good.
Do you want me
Oh.
to share my screen and show what I did?
Yeah, if you want. I don't want to take forever.
Okay. Well,
This has been one of my weeks, and so just like Jamie was saying, I'm not going to take your guys' time for my inability to get done what I need to. So if you guys are fine with it, we'll move on. I'll figure it out.
well, I know how it feels to not understand something, and you guys have taken time to help me. So
Well, I know, but I'm not understanding it because I put in the effort. Is what I'm telling you. I didn't give it the time. So
okay.
when we get off, I'm fine. So if we want to move forward and you guys are good, I'll be fine.
Okay, well, just know that that's the formula for the margin of error.
Yeah.
If you have a question, you can always text us.
Yeah, I'm good.
Okay.
So D is construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years.
I got 0.6511 and 0.708. 7, whatever.
Yeah, me too. Yeah, that's the same number.
Is that what everybody else got?
Yeah, that's what I have for that.
I'll read E if we're ready.
Mm-hmm.
Yep.
How many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015? This one I used the n equals the z star divided by 2m raised to the second power.
Yes. Okay.
So I did 1.96 divided by 2 times the 0.015 and square rooted that whole thing. And got 4268.444. Then you round it up to 6269 or 4269.
Yeah. So 8A, state the null. Okay. Now you are interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information above and use a level of significance of 0.05. So the null is that the proportion is equal to 0.6, and the alternative is that the proportion will be greater than 0.6.
That's what I got.
And then compute the test statistic for B.
Yeah. That was interesting.
Did you guys get 5.173?
I got 174. 5.174.
Okay.
But what I don't understand is why we computed the Z to get the Z score. I mean, to get the, well, I don't want to, I'm just asking a question. Why do we do the Z to compute the test statistic? I don't understand that. I did it, but I don't understand it. Anybody knows? Quickly.
I have no clue.
No clue. Jesse, do you know why you did that?
Because it said to. I don't know.
But
All
we
right.
do.
All right. Woo.
There's no logic. We just do it. That seems like math most of the time.
Math to me, it's like why? Because it told me to. Okay.
Okay. Moving on.
Okay.
Let's see. C. Oh, this is another one of those.
I was confused on this. I know, like, you shade the shade the right,
Yeah.
but when you put in the 5.174, you know, it gives you that E with the
Mm-hmm.
whatever. How do you find, like, how do you figure it
write
out? Yeah.
Okay, so if it says, for example, I can't remember what it said there. 1, 2, 3, 4, 5, 6, 7. I think it said 7. -7, didn't it? E -7 or something like that.
Yeah, something like that.
Okay, so if it says -7, then what you do is you get the little the point and you move it 7 spaces to the left.
Oh, okay.
If it doesn't say negative, then the decimal point will be
Can you
going
move
to
it
the right.
to the right? Okay, that makes sense.
So that's how I remember it.
Okay, thank you.
Okay, so D. Oh, and how did you compute the P value there? You had to write down where the P was. How do you figure that one out? The line? I don't know if you remember. Did you do that at all? It says sketch your P value on the normal distribution curve. I didn't do it. No idea. Okay. Yes?
I don't know.
Do you do it?
Yeah, I'm absolutely no help at this point.
Okay. All right. So D. What is the decision you make about the null hypothesis? I put reject the null. You want to take E, Jamie? I mean, Jesse?
Yes. I rejected the null.
And what's E?
E is, we have sufficient evidence to say that true proportion of students that have been in a car wreck within the last 5 years is greater than 0.6.
Yeah. I did something similar. Okay. So shall we move on? Anybody have questions?
Nope.
Not for the time being. Nope.
Okay.
Okay, let's start the quiz. This is good. Honestly, I feel like, I don't know, I feel like this approach will just motivate me to, and hopefully everyone that isn't keeping up. And I think we all have our moments where we're not, but I just think it'll motivate us to get it done ahead of time. So I don't know. I don't know if you guys agree, but I feel like it's a good thing. It's making me feel like an idiot. So
Well, never mind. I'll
no,
tell you guys.
go for it.
The thing with me is that it's not that I don't like just get it done. For me, I'm dealing with some health issues right now, and so it's really hard for me sometimes to get assignments done or things like that because my brain just can't focus.
Mm-hmm.
And so if I come to class with if I'm not prepared, seem like I'm not prepared, or if I don't talk much, it's not because I'm not trying to it's not that I'm not wanting to participate, it's just some other things going on. So
Mm-hmm. Yeah, no, and I appreciate that you say that. I don't know. I don't know what the balance is because that's completely understandable. But when I don't participate, that's just me being lazy, right? Because I don't have a valid excuse. So I don't know. I don't really know what the balance is. And
I just felt that I should let you guys know because I should have let you guys know at the beginning of the semester, but I just kind of kept it to myself.
yeah,
But I just thought I should let you guys know that because
You're totally fine. To be honest with you, I have not felt anybody is pulling anybody else down in this group.
yeah. Well, and I think we all just have our moments too.
Yes.
Where we're on top of it or whatever, and then other times where we're not as much. I don't feel like the equal, I don't feel like it's super off balance or anything by any means.
No, but don't beat yourself up either too hard, Jamie. It's not.
No, I'm trying to kick myself into gear, I think, by
Yeah.
which is hard because I think my class load this semester is just probably too much to put priority anywhere, but that's my own.
Yeah. And so to you guys, and that's it. That's the first time I've shown up to class without it. And same thing, I was off doing another assignment.
Yeah.
And ended up an hour longer at a school than I anticipated, and so here I stand. So everybody's I think gone through it. So I don't think anybody should feel bad about where we've come. I don't in this semester. I don't think anything of any of you.
Yeah. No, I think we're all aware that our energies, just are spread thin. We have so many things going on. So.
Yeah, week 9 is showing, right?
Yep. Okay. So quiz. All right, I'll read question 3. So we'll be using the normal probability applet. Question 3. The symbol for the true population proportion is which of the following?
It's the middle one.
P hat.
Anybody agrees or disagrees?
I still got mine coming up. But there it is.
The true population proportion.
I'd say it's the second one.
I'm still confused about that. That's why I'm guessing.
Well, I thought that the true population was P, and the sample was P hat.
Yeah, in the textbook, it says the reason the study was conducted is to provide an estimate of the true population proportion, P.
So it's P.
Yeah.
That's what I think. The P hat is your sample of that population.
Oh, yes, okay.
Okay, does someone want to pick up 4?
I will. For the next two questions, suppose n equals 100, p equals 0.25, and p hat equals 0.10. The requirements for constructing a confidence interval are satisfied, true or false?
I'm going to say yes. No.
So are we gonna have to?
Use that formula, the requirement formula.
I can take, I think it is true.
It's true, isn't it? They're both higher than 10.
I'm still figuring it out. Yeah, I'd say true. Because it's 10 and 90.
Yeah, the P hat is.
Isn't that what the requirement is? Oh.
Well, there's two different things there. Are we supposed to be figuring both, or?
For the first one, for number 4,
Yes, we're just doing the P
Well, they
hat
both
one.
are. They're both higher. So it's true.
wait a minute.
Why? this one's looking for the confidence interval, and that's the one we use for the confidence interval is the NP hat is greater than or equal to 10, and then N times
Right, which is 10 and 90.
Yeah.
Okay, but
I said that.
that's why you got 90. Because I didn't get that.
You didn't get 90?
No, I did the 25 instead of the 10. So
Oh,
you
well,
used
it's the P hat one.
How do you know which one to use when?
Well, I wrote it down as a confidence interval requirements, and the other one is the hypothesis requirement. So we're doing both of them because the next question is looking for a hypothesis test.
Oh, now I erased everything.
So wait, which formula do we use for confidence interval?
N times P hat is greater than or equal to 10, and then
Okay.
N times 1 minus P hat is greater than or equal to 10. That's what you're checking.
So 90 is greater than or equal to 10.
Mm-hmm.
And that's for number 4 still? Okay.
Mhm.
So
Yeah,
because it's greater, it's true?
Yes.
Greater.
Yeah, you have to plug it into both, yeah, so it's 90 and 10 is what the
Okay, yeah.
answers are.
So then we use the other one, the N times P hat is greater than or equal to 10. Is that the one we use for 5?
Yeah.
Okay.
Not the P,
No,
not P hat for 5. P hat is for 4.
Yes, and the P is for the 5,
Yeah.
right?
Yes.
Right.
They just want to mix us up.
Always.
That's not very hard to do on this end.
I already said it.
Okay, so we all agree on true for question 4. Is that correct?
Yeah. Yeah.
Okay. And then for question 5, what was the conclusion?
Did you plug in? So it's 100 times 0.25. And then 100 times 1 minus 1, or 0.25.
Yeah, it's true too, right?
Yeah.
Okay.
Okay.
We're ready for 6.
Yes.
Mm-hmm.
A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find P hat, the point estimate of the proportion of the first-degree murder defendants who are found guilty in this state, round to 3 decimals.
What formula do we use?
Isn't it the
Oh, is this the This would be the, is this the 45 divided by 60?
Yeah, that's what I'm thinking.
Yeah.
Oh,
The
just that.
X
Oh,
over
oh, oh.
N.
Oh yeah, okay, okay. Sorry.
That's fine.
0.75. This is round to 3 decimals.
I know that kind of threw me off, so I did it again, but it's 75 on target.
I just added a 0.
Oh, okay. And there you go.
Okay.
Who wants to take the next one?
I will. Create a 95% confidence interval for the true proportion of first-degree murder trials in this state. Murder trials in this state, there the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. So determine the margin of error for this 95% confidence interval.
Okay, so then it's that Z. What is it? 95% would be
1.96.
Okay.
So it would be. What are we doing?
So what is the formula we're using for this?
The
Sorry.
Z, the critical Z, square root of P hat times 1 minus P hat over N.
So it's 1.96 times. But we don't have the P. Wait.
This is where I get a little confused.
We just figured that, right, in the last one?
Yeah.
P hat would equal X over N, right?
Yeah,
So it'd be the 0.75.
that would make logical sense to me.
Good, it's logical.
Uh-oh. No, I don't want to be claimed as logical.
So 196 or 1.96, sorry, the times the square root of 0.75 times 1 minus 0.75 divided by 60.
That's what I'm thinking.
It's just typing it in right in the calculator. I feel like if you, I don't know, it's just the order that's tricky, I feel like.
So 0.1095.
So it'd be 0.110.
I got
Wait, 0.
I think I got what you got, Jesse.
That's what I got, 0.10956, whatever.
Mhm.
Yeah.
So, but if we're going to go to the third, then we got to round that up. It would be 0.110.
0.100. 0.10.
No, 0.110.
Oh, yeah. Okay.
Because 109, it go up to 110.
Input.
Wait a minute. What is it?
Well, if you're rounding to the third decimal, the third decimal would be 109, but then you have the 5, so it would be 110.
What? 110?
Yeah, so you'd be at 109 and you'd raise it up to 110.
Oh yeah. Oh yeah. Oh, yeah. Thank you. See, you're doing really good today.
For being behind the 8 ball, I think so.
Yeah. You're good. You're good. Okay, so upper bound and lower bound. Ooh, how fun.
Isn't this the?
Wait, okay, sorry, but on 7, did you say 0.109?
Mm-hmm.
Okay, good, I just got that. All right, I'm on
But you're rounding.
the 0.110.
Yeah.
Yeah.
Oh, yay, okay, got it. Sorry, keep going.
Our X was 45, right? N was 60.
Mhm.
And we're at a 95% confidence level, correct?
Yeah.
Okay, so if I plug that in, the p hat is 0.75. You got that right. Our confidence interval should be 0.64 and 0.86.
That's what I got.
Are you guys plugging things in the template?
Yeah.
Well, I did it by hand, but because I forgot that there's a template.
If there's an easier way, you'll find me there.
Yes.
0.860.
So, did you put greater than?
Let me check. Yes. Is that what we need, right?
Don't get them mixed up, guys.
For the true proportion of the first degree murder trial. Yeah, because it's supposed to be to the right, right? It's supposed to be greater than.
I get that. Do you need a hypothesis? No. Just for the template, or you just leave it the way it is. If that doesn't matter.
No, I left it the way it was.
So did you get, for the confidence level, did you get 0.6, 0.640
Mm-mm.
and 0.860?
You got 0.64 and 0.86.
Did you get that, Jesse?
For the lower bound, I got 0.64, and upper is 0.86. So what Jeff got.
You did yours by hand, right?
Yeah.
So we should be good.
And I just added a 0 because it says
Right.
round to 3 decimals.
Are we ready for the next one?
Mhm.
Yep.
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? It decreases.
Yeah. Okay. And then question 11, to conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals half. What is the smallest N can be and both requirements still met? I feel like this is another one of those guessing games, filling in numbers.
So if we take n times 1/2 greater than or equal to 10, that would be 20. And then if I take n and minus half, that would be 0.5.
What is the smallest N?
Did you guys get the answer? Did you guys get 30?
Which one was 30 for you?
Both of them.
No, the first one's 20.
What?
It's half times 20 equals 10.
Why 20?
You divide both sides by half, and that gives you 20 on there.
Isn't it, wait a minute. Isn't it 60 times 1/2?
But that would be 30. And it only has to equal 10 or greater on that for it to work for that first one.
Well, it is, 30 is bigger.
Right, but 10 also works. So 10 is the lowest for that.
But we're looking for the smallest.
Right.
So it would be 10. And
No, I don't understand what you guys are saying.
yeah, I don't.
So,
Because 20 times half equals 10, and 10 is the smallest number that would work in that formula, because 10 is greater than or equal to 10, and we're looking for the least amount that would work. But as for the second one, that's not the case. It's not 20. I don't know. I didn't explain that very good.
Okay, okay, let me start from where I'm stuck. So we plug in the 60 for the sample, we plug in the 1/2 for the P. So we times that by 2, we get 30, correct? I mean, not by 2. We multiply those two and we get 30, right? So long.
All right, why are we, I'm gonna back up a minute. Why are we using 60? Where are you getting that from?
60 is a sample size.
No, we were only supposed to use that for 5 questions. So that was 6, 7, 8, 9, and 10. This is just this is asking by itself. So we're putting in P. We don't have an N.
Oh, so you're looking for N.
Yes.
Oh.
That's why I was lost. I'm like, wait a minute, where did I miss the 60?
I'm sorry, guys. I'm so sorry. Okay. So we're looking for the N. Okay.
And so that would be N times 0.5 greater than or equal to 10. So that answers 20.
Okay. Now I'm still confused here. What formula are you guys using?
We're just.
You got to use your N times P greater than or less than 10, and then the N times 1 minus P greater than or less than 10. And so they give you the P. So, but the way I'm seeing this one, they're both 20, right?
Wouldn't, so P would be 0.1, right? For 12? Because if you're putting the 1/10.
What do we get on, what did you guys put on 11?
On 11, I got 20.
Okay. Because both of them came out to 20, right?
Oh, I see.
Oh, you mean, okay, yeah.
When you run it both ways.
I see what you're saying. Hold on.
Because the 1 minus the half actually gives us half. It's actually the same thing.
Yeah.
Yeah.
Right?
Yeah.
Okay.
Yeah.
Right.
Are you with us there, Ruth?
I'm using the formula for the N that when you don't know N. Right?
Yeah, you're talking about me. Don't know N. Don't know nothing. You're right.
So you would just use N times 1 minus P is greater than or equal to 10. Is that correct? So we don't know N, but we're going to manipulate the problem. So we know P though. So we're going to manipulate everything to the other side, and then it will give us N.
It could be that. I think you'll get the same answer, but
you know, we did this the other day, Ruth. You and I had the same answer. So whatever you were using,
there's a formula here that says if we don't have the prior estimate, the P, then you use this.
But we're not given like the Z and stuff. We don't need.
Yeah, I don't know what she did the other day, but she came up with the same answer that we had. So
I don't know what I did either.
Well, let's try it.
Yeah, this was the one I think we were all kind of stumped on the other day too. Just
Yeah, but we ended up with the right answer, so.
Right. Yep.
So what did you guys get then?
20.
20.
20.
But there are more than one way to skin the cat, so.
True. Whatever works.
Yeah, and whatever works in your brain and what you've got in there, you got to go with.
So how did you guys end up doing that? Manipulating the equations?
Yep.
Okay. You guys can go on if you want.
Does that make sense though? Do you understand the process or a process that works?
Well, you just n is going to be the first one 10 times 10 divided by 1/2, right? Which will be the 20. I got it now.
Okay.
And then the other side, you just manipulate it to go the other way. Yes, I get the process.
Great. Okay. So question 12, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/10, what is the smallest n can be, and both requirements still be met. So this is the same process again, right?
Yeah.
I got 100 for this one.
If you run it on the second one, I think it's 11.11. 11.11.
Well, if you do 11.11 times 0.1, it equals 1.111. Because P would be 0.1, wouldn't it?
Yep.
Yeah, so 11.11 times 0.1 is 1.111. That's not greater than 10.
So for the first one, I got n equals 100.
Right.
That's what I got.
But the second one is 1 minus 0.1.
Which is 90.
Which gives us 0.9.
Yeah. And if
So
you
if we
do,
take 10 divided by 0.9,
why would you do 10 divided by 0.9?
because you got to divide by 0.9 on each side to get rid of it.
Yeah.
I just did 100. Wait, but isn't it n times 1 minus p?
Yeah, so n times 1 minus 0.1, which is the
Yeah.
0.9.
Which
And
is the 0.9, so times 100 equals 90, which is still greater than 10.
But we don't have n.
Did you substitute the n with 100?
I did.
But that's what
Oh,
we're trying to figure out is n.
Yeah, you
Well,
can't.
I'm
You
just
don't,
guessing.
yeah, don't put the 100 back in the second one.
But but it's n.
It was n for the first, but it's not necessarily n for the second. That's what we're trying to figure out.
But I know, but you don't have two different answers for n. You're trying to find what the smallest n could be. So why would you have two different n's?
Because it has to pass both tests.
That's what I did.
Yeah, except for you're using the n from the previous one to plug it into the second one. But you're trying to find n on both ones.
But so you're using two different n's then.
Yes.
Yeah, to figure
Why?
out what works for both.
Because it has to pass both those tests.
But it
Otherwise,
did.
otherwise it's not proportionate. Well, you're using, I don't know. Unless I don't know where did it say to use that?
What was the answer you got, Jesse?
90. I mean, I definitely could have missed that because I didn't read through the section, so.
But if you're following the same pattern as the last one, then you wouldn't use that.
What the are you? Okay, you guys said for number 9 or for number 11 that the answer is 20, right?
Yeah.
Yeah.
Okay. So what I did was plugged in. I just guessed 20 times 0.5, which is the p, and I got 10. So that's greater than 10. So what did you guys do for part 2 for the second part?
Oh, well, see, we weren't guessing the number. On that top one, if you take and divide 0.5 off of the first side, you have to do it to the second side. So you divide 10 by 0.5 and it gives you 20. I see what you're saying. And so then you took and put 20 down into the bottom on the end.
Yeah. So what's your answer for 12 then?
11.11. Right, Jeff? Is that what you got?
Yeah.
Yeah, but if you plug 11, which that's what I got too, but if you plug 11.111 into the first problem,
It doesn't
if you put
work.
that, if you put that as n on
But
n times 1 over
that's
10.
what we're talking about. You guys are going between and trying to plug it back into the one before, but they're not the same.
No, you do have to plug it into the first because that number that we put in this answer has to be right in both solutions. So you have to plug it back in to see if it really does work in that solution. And if you do put that number back into the first solution, it doesn't work.
Well, it's not going to meet the smallest requirements for the first one, but we have to find the smallest requirements overall. So it does still work. It's just not ideal for that one, finding the smallest, but it's the smallest for both. So we have to cater to the one that's higher.
At least I understood from the instructions that it had to be for both.
That it had to be both.
Yeah.
Well, maybe this is just one that we agree to disagree, because I don't think I'm going to be persuaded differently, which is fine.
Yeah, and I'll have to go back and study. Because I'm taking it as two different problems, and we're trying to see which one's the lowest. And if one of them's over and one of them's lower, then it doesn't work. This isn't being met. But to me, it's two separate problems, and it has to fit. Both of them have to be over the 10 in order for it to be distributed in a normal fashion.
Yeah. Well,
And that's why I said, so if you guys want to go where you're going, because you guys probably both read it more than the two of us that are on the other side.
so Jesse, what did you get for 12?
I don't know anymore.
Okay, I'm gonna put 100,
Okay,
just so you know.
cool.
That's what I was gonna put, but
Okay.
Okay, well, let's just run with that. And I think it's going to be best if we just, I don't know.
Yeah.
I feel like we're all pretty confident in our answer, maybe. So let's agree to disagree.
Okay. Moving on.
What are we on, 13?
Yep.
Yeah.
All right. Let's see. Well, 13's for the water quality study in the reading. About 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level 95%, 0.05, with the following hypothesis: P equals 0.6, or P is less than 0.6 for the alternative. They collect data in this time N is 80, and X is 38, indicate good health. 13, the condition for conducting a hypothesis test are satisfied.
So I got true. Is that what you guys are thinking?
Yep.
Yep.
Okay. Are we good to keep going?
Yeah.
Question 14, what is p hat?
0.475.
So p hat, is that determined x over n again?
Yeah.
Okay. Okay. I'm
Is
the
this
test.
is this the z times the square root of the p hat 1 minus p hat over n?
No, I think this is the x over n, isn't it?
For the test statistic?
That would be the z p hat minus p divided
sorry,
by square root.
I'm on 14. Sorry.
Oh no, that's okay, sorry. What is it, Jeff?
So that would be the z equals p hat minus p
Oh,
divided by the square root of p times 1 minus p divided by n. I think that's the one you're looking for.
wait, so it's p hat minus p divided by the square root of p minus 1 minus p divided by n?
Yeah,
Okay.
that's what I have written by the test statistic.
Yeah, I do too. I was just making sure.
Okay.
What did we determine for P?
We didn't, they gave it to us, it was 0.6.
Oh, right. Sorry. Okay.
I got negative 2.2822.
What was our n was 80, right?
Mm-hmm.
What did you say, Jesse?
Negative 2.282.
Okay. Because I just got negative 2.314, which is close, but let me try it again.
Yeah, it's negative 2.282.
Okay.
And then to find the p-value, don't you plug it into the normal probability app?
Yes.
Yes, you could do that.
And then you shade the left.
Yes.
What did you guys get? Negative 2 point what?
282.
Okay. Yes, I did. Whew, that's a long little problem there going on. Whew.
So then I got the p-value of 0.011.
Yep.
So reject the null.
Which is not what I have from.
So that's shading the right. Is that correct? 0.011.
I shaded the left.
Oh, I guess it's the same either way. Okay.
Wow.
Okay.
Oh, wait, it's supposed to be here. That changes that. Where is it going? 0.011.
And then what is the decision for this test?
Reject the null. Right.
When he said we were doing qualitative now instead of quantitative, in my mind we were just going to be doing a whole different ball game, but this is really kind of the same. So when we reject the null, we have sufficient evidence. There's sufficient evidence.
So do we have sufficient evidence?
When we reject it, yes.
That's what I'm asking on this one though, do we?
Do we reject it?
I'd say yes, but that's just
I
me.
thought it had to be greater than
No, when it's
0.05
no,
to
that's
reject
when
the
we
null.
that's when we fail to reject the null.
I think you're right. Now that you're saying that. Okay.
So how do you know what side to shade, guys?
Because you're looking
Because
for
I'm-
less than.
Oh, yeah.
Yeah, when P is less than A, then we reject the null.
Okay. And it certainly is smaller.
So then the conclusion would be there's sufficient evidence to conclude that the water quality in the area has decreased.
Yeah.
For the last one.
Yeah.
Ruth, are you up to speed? Do you have any questions?
No, I don't have questions. I'm just behind. I'm doing the shadings right now of the output. I'm on 16.
Oh my gosh. My computer is being dumb.
You see, I never got my picture back over here, so
Yeah.
mine's right along with you.
I thought you were
Except for when
hiding
we-
your morning hair.
Ooh, missed one somewhere. Where was it?
So do we shade both the middle and the right?
No, just the
No,
left.
just the left.
Because it says greater than the negative 2.2 whatevers. And starting at negative 2.2 whatevers would be the middle and the right. I don't know. Am I reading that wrong?
I got 12 right.
What do you have on it?
That one was 100. That's the one Ruth and I were agreeing on.
I'm lost on that one, so but I'm lost on this whole assignment, so we're good.
Good job, Ruth. You and I got that one right.
Yeah, okay. Okay, so I'm still working on number 16. So is the p-value 0.9888?
You got 0.011. Because if you type in 2.282 is the z-score and then shade left.
Oh, left.
Yeah.
Oh, shoot, I did the wrong thing. Thank you. Do really well. I'm getting mixed up on the shading thing. Okay, I see it. Thank you. Got it. So should we talk about, are we good, everybody?
Yeah.
So should we talk about, should we do that design the study thing?
Yep. Let's get her done.
Okay, well, who wants to write it up?
Should we start a Google document that we can all look at?
Shoot, no, there goes something new. I think that's the best thing to do, but
Yeah, I'll share a page with you guys. So just go onto your Gmail or Google Docs. What? Okay, I just shared the document. So. So I'm pulling it up now, but do you guys know? So we're just designing the study. Are we just writing up a sentence or two proposing what we're doing? Just it's a pretty quick thing, right?
Sure. So it is when you know what you're doing. So let's start with, how do I go to my Google Docs? How do I go there?
That would be a problem.
I've done it once in my lifetime.
Just go to your email.
Google.
Yeah. Yep.
Okay. Okay, I'm gonna. You just gotta be patient here. Okay, so Google.
I'm gonna stop the broadcast. I don't think we need to broadcast this part.
So this